Hello everyone, so this is another math counts problem. So this was a national target run problem. So that was a number 8, okay? So which meant to be most challenging problem on the test, and you should spend like 3 minutes if you can actually handle this one. So we have unfair coin that is flipped 5 times. Okay, so let me highlight these. Okay, and the problem of getting a heads up more times than tails is 31 times. Problem of getting heads up 5 times. Okay, it's kind of a bit challenging, so slowly read and digest every single step. And what's the problem of getting coin that is gonna be heads up? Okay, so we wanna have like flipping that coin 5 times, and we wanna have more heads than tails. Okay, so let's think about the cases. But before I do that, I like to say problem of getting a like head. Let's say this is P, and problem of getting a tail is gonna be 1 minus P because the total is just 1. And what we were told, we wanna get more heads. So I could have 3 heads and 2 tails. I could have 4 heads, 1 tail, or I could have five heads, right? So this is what we want. So we are told getting like what this is 31 times getting heads up 5 times. Okay. So when you find the problem of getting this, that will be 31 times getting 5 heads. Okay. So again, this is not really nice way of saying it, but when you write the equation, but I'm just kind of trying to show you what we are dealing with. Okay. So, getting a 3H and 2 tails could be done this way. So let me write that in our next step. So if you are getting a H, that's P. H is also P, like that's a probability. So that's 3 times. So we should have P to the third. And then getting 2 tails is 1 minus P times 1 minus P. So that needs to be squared. But here's the problem with this. I can get 3H and 2T's in this order, but this is not the only way that I can get 3H's and 2T's. Like I can really rearrange those order. I can get 2T's first and then 3H's after, or I can like get H, H, T, T, H, or I can get a lot of different ways. So to find number of ways to get 3H's and 2T's in this manner, it's basically you want to choose 2 spot for 2T's, and whatever left will be H's. Or if you want to choose 3 spot for H's, the whatever left is going to be T's. So another way of saying it, you like to choose 2 out of 5. So which is 5 choose 2. So you can rearrange these 5 choose 2 ways, which will be 10. That's the first part. And plus, okay, the second part is 4 H's, which is P to the fourth, and a 1T, 1 minus P. But again, we have now 1 spot for T, so we have 5 places that I can place that T, so that is 5 ways to do so. Or you can just do 5 choose 1, which is just 5, but I just didn't do as choosing way, okay? And the last one is P to the fifth, right? Because we have 5 of those. And then there is only one way to get this order, so I don't really need to multiply that by 1. That's the same thing. This is equal to 31 times this guy, which is actually the same as P to the fifth power. And I do have a nice equation that I need to deal with, right? But let me complete this first. Maybe that's 10, right? And that's 10. But I have P to the third, P to the fourth, P to the fifth, P to the fifth. So all the terms in this sum, in this equation, has at least the third power of P. So I can divide everything by P to the third. So this will cancel. So you will get 10 times 1 minus P squared. And that will be 5. And then if you divide this by P to the third, so you will just get 1P less. So 1 minus P. And if you divide this by P to the third, so that will be P squared and equals 31 times P squared. I hope that makes sense. If that doesn't, so please like slowly complete this middle step. I just divide by P to the third. And I can now expand this. So I have 10. If you expand 1 minus p squared, so 1 minus 2p plus p squared, that's my square of binomial. And p times 1 is 5, p, that's 5 times, so 5p. And p times this will be minus p squared, that's multiplied by 5p squared. And I can subtract p squared from both sides, so to make it a bit less complicated. So that's what I have, but that doesn't look like we are done yet. So if I simplify this, 10 minus 20p plus 10p squared and 5p minus 5p squared. Okay, I think, yeah, that's the case, equals 30 p squared. So, we have 10p squared minus 5, which is 5p. If we subtract from both sides, so you got 25p squared. Okay, and then you have 5 minus 20, which is minus 15p on the left side. So if you add the both sides, so you got 15p. And then I have 10, and then subtract from both sides, so that will be minus 10 equals 0. So all the terms divisible by 5, so let's do them. So that will be 5p squared plus 3p minus 2 is equal to 0. So at this point, if you want to use the quadratic formula, go for it, but I will try factoring, okay? So since we have 5p squared, so I should have 5p and p, and then I have 2, so that means 2 and 1, or like 2 and negative 1 actually, or negative 1 and 2. But at the same time, I need to get middle term as a positive 3p, right? So that looks like 5 minus 2 works, okay? So to do so, I should have plus 1 right here and minus 2 right there. But let me confirm, because I did all these work, I don't want to mess up at the end. So 5p times p is 5p squared. 5p times 1 is 5p. Negative 2 times p, negative 2p. So 5p minus 2p is just 3p, which is nice. Negative 2 times this will be negative 2. That looks good. So the product is 0. So p has to be 2/5 or negative 1. But at the beginning, I said P was the problem of getting a head. So problem of something cannot be lesser than 0. Okay, so which is why I will discard this one. So only choice that we have is 2/5, which makes sense. 2/5 is a number that is less than 1 and larger than 0. So which is expected as a problem. Okay, so that's the answer. So I hope that makes sense. I'll see you in the next video.